Beneath the sand dunes of the Arabian Desert, 2 kilometers down, lies the largest single deposit of conventional oil ever discovered on Earth. The Ghawar field, 280 kilometers long, 30 kilometers wide. A reservoir larger than the entire city of London, filled with light crude oil worth over $3 trillion. Every single day, this one field produces 3.8 million barrels. 6% of every barrel of oil used on Earth comes from one desert in Saudi Arabia. Production cost, $10 per barrel. The cheapest oil on Earth, while the world pays $70. The profit margin, that funds everything Saudi Arabia is. Today, we go inside Saudi Aramco's desert oil machine. From the geological survey, to the drill bit, to the pipeline. The complete story of how the world's most important oil field works. It begins 320 million years ago. The Arabian Peninsula, a shallow tropical sea. Marine organisms lived, died, and sank. Layer by layer, organic matter accumulated on the seafloor. Over millions of years, heat and pressure transformed the organic matter into hydrocarbons. The oil migrated upward through porous rock until it was trapped by impermeable layers above. The anticline trap, the Arabian Reservoir, Jurassic mudstone, 100 meters thick, lying 2,100 meters beneath the desert surface, saturated with the lightest, most valuable crude oil in the Middle East. The seismic survey came first. Vibration trucks drove across the desert, sending sound waves into the earth. The reflections mapped the underground structure with precision. This was the map that led to Ghawar. The first discovery well, Ain-Dar No. 1, was drilled in 1948. It found oil, 15,600 barrels per day from one well. The men who drilled it could not know they had found one of history's greatest treasures. As of 2026, 48 billion barrels of proven reserves remain. At current production rates, Ghawar will produce for another 35 years. The oil that powered the 20th century will power deep into the 21st. Before a single well is drilled, the earth must be heard. Seismic exploration. Vibrations sent into the desert floor. Reflections from underground rock layers recorded. The acoustic portrait of what lies beneath. In 2026, Aramco deploys drone-based seismic acquisition. Unmanned aerial vehicles flying grid patterns, sending vibrations through the earth from the air. Faster, cheaper. No roads needed across the empty quarter. AI interprets the data. Machine learning algorithms identify reservoir characteristics. Porosity, permeability, oil saturation, with accuracy impossible for human analysts alone. The result? A precise drilling target. The rig arrives. 60 trucks, 48 hours. A drilling derrick 40 meters tall rises from the desert floor. The temporary city of steel that will drill 2 kilometers into the earth. In 2026, Aramco's walking rigs. Instead of dismantling and reassembling between wells, this rig walks. Hydraulic feet move at 50 meters to the next well location. Time saved, 3 weeks per well. The driller's cabin. One person controls thousands of tons of rotating steel 2 kilometers below their feet. Every parameter monitored in real time. Weight on bit, rotary speed, mud pressure, rate of penetration. Horizontal drilling. At 2 kilometers depth, the drill turns horizontal, following the Arabian Reservoir layer for another 2 kilometers sideways. One well contacts 4 kilometers of productive reservoir. Maximum reservoir contact. The drill bit. Polycrystalline diamond compact cutters. Harder than any natural rock. Rotating at 100 revolutions per minute. Generating temperatures hot enough to melt lead, the piece that touches the earth. In the Ghawar shale basin, Aramco's engineers developed ultra-strong diamond bits to cut through abrasive rock without overheating. Bespoke technology for the punishing desert environment. A $100 billion project. Drilling mud, the unsung hero. A precisely engineered fluid pumped down the drill string. It cools the bit, carries cuttings to the surface, controls formation pressure. Without it, catastrophe. Blowout prevention. The BOP stack. Steel rams that can close the wellbore in seconds. Tested before every well. The last defense against an uncontrolled pressure release from the formation. Perforating. Explosive charges fired through the casing and cement, creating channels into the reservoir rock. Oil flows from the Arabian carbonate, through the perforations, into the wellbore. First contact with the reservoir. First oil. From a new Ghawar well. The engineer's face. 75 years of Ghawar history behind this moment. The field that defined a century, still delivering.
The drill bit, the piece that touches the earth. Polycrystalline diamond compact cutters, harder than any.
In the Ghawar shale basin, Aramco's engineers developed ultra-strong diamond bits to cut through abrasive.
Weight on bit, rotary speed, flow rate. 3 variables, each affecting rate of penetration.
Clear the roughneck. Coming up. Watch the joint.
With Aramco's automated pipe handling systems, tripping time cut by 40%. Robotic arms handle the pipe.
How are the flow rates looking?
We're maintaining steady pressure
but the viscosity is high.
Drilling mud, the unsung hero of oil drilling. A precisely engineered fluid pumped down the drill streams. The mud engineer, the chemist of the drilling operation, adjusting the mud's density, viscosity, and filtration.
In Aramco's Ghawar project, a unique challenge, injecting water into shale rock to
The shale shaker. Vibrating screens separate the drill cuttings from the returning mud. The mud is recycled, cleaned, reconditioned, and pumpers. Blowout prevention. The BOP stack, the last defense against an uncontrolled pressure release from the formation. Steel
Casing is critical. We run the steel pipes deep into the well, then pump the cement slurry down to secure the well bore.
casing. Steel pipe run into the borehole in sections, telescoping from large diameter at surface to smaller Cementing. Liquid cement pumped down the casing starter and back up between the casing and the formation wall. When it sets in,
cement bond log, an acoustic tool run after cementing to verify the seal. Any gaps, the well must be squeezed.
perforating. Explosive charges fired through the casing and cement to end, creating channels into the reservoir rock. Oil flow. First oil from a new Ghawar well, the engineer's face. 75 years of Ghawar history behind this moment.
Okay, team, confirm all pressure levels are stable. We are ready to set the tree on the casing. Send it down slowly.
This is the final stage. Running the completion tools ensures the well is ready for high-pressure production.
Sir. The interval control valve, Aramco's innovation, installed on horizontal wells at multiple points, allowing
Artificial lift. As reservoir pressure declines, pumps are installed to lift the oil to the surface. Electric submersible pumps.
At Ghawar, thousands of completed wells, each one contributing to the 3.8 million barrels per day.
Each well has a personality. Some produce dry, some produce water. The challenge is optimizing.
Okay, little pinch now. And all done, you did great.
Ghawar's secret weapon, water injection. Since 1964, seawater has been pumped into the Arabian Desert.
7 million barrels of seawater injected every day. More water than the entire city of London uses in a week.
The Kharg seawater treatment plant. On the Arabian Gulf Coast here, seawater is treated to remove oxygen and sulfate
The water cut, the percentage of water rises as
CO2 injection, a newer technology. Carbon dioxide captured from the processing plants, injected into.
This is the digital twin of Ghawar. Our AI is predicting a significant increase in production from this sector alone.
With EOR, Aramco has maintained 3.8 million barrels per day despite natural reservoir decline.
This laser processing station utilizes a high-intensity beam to achieve a flawless, mirror-grade finish on even the most complex geometries.
From the wellhead, the produced fluids flow through flow lines to the gathering station. Oil.
We use the three-stage separation process to efficiently recover the gas at sequentially lower pressures.
Stabilization column. Light volatile hydrocarbons removed from the crude oil. The oil's vapor pressure reduced to specification.
The gas plant. Associated gas from Ghawar processed at Hawiya and Uthmania plants. Liquid hydrocarbons extracted, sulfur removed.
Crude metering. Every barrel counted. Flow meters calibrated to international standards. The measurement that becomes.
The Abqaiq processing plant, the world's largest oil processing facility. Every barrel from Ghawar passes through it.
In this section, Pipeline and Export, we'll review 7 clips covering both voice and visual elements.
The pipeline network. From Ghawar,
crude oil flows through thousands of kilometers of pipeline across the
Tanura, the world's largest offshore oil loading facility, capable of loading up to 9 million barrels per
The loaded supertanker. 2 million barrels of Ghawar crude, Arabian Light, heading for refineries in Asia, Europe, and America.
Aramco's control center in Dhahran. One room, the entire kingdom's oil production, monitored in... Saudi Aramco produces 12 million barrels of oil per day, more than any other company in human history.
Production cost, $10 per barrel. Revenue, $70. Profit per barrel, $60.
This income triple, it funds Saudi Arabia's schools, its hospitals, its roads, its military, its Vision 2030.
The telemetry shows the valve response is lagging. We should initiate the automated adjustment sequence immediately.
The digital oil field. 50,000 sensors across Ghawar, measuring temperature, pressure, flow, and the thanks to the AAI.
Here in the virtual field, we can run countless production scenarios, minimizing risk and maximizing.
In 2026 Tunri, 85% of Ghawar's wells use enhanced oil.
Carbon capture. The Uthmania CCUS project captures 45 million cubic feet of CO2 per day and inject
Water recycling. Produced water owning once a costly waste stream, now treated and re-injected. Nothing wasted.
How is the throughput on line 3?
We are meeting the target, just finalizing this batch now.
68,000 employees. Saudi Aramco, the largest employer in Saudi Arabia. Engineers, geologists,
the Aramco engineer, university trained. Many at KAUST, Saudi Arabia's science university, returning to work on the
Women in the field. Aramco's women geologists, engineers, and operations staff, once rare.
The shift, 12 hours. The desert heat, 50 degrees Celsius. The work.
Outward. My father worked this field. I work this field. My son is studying petroleum engineering.
I finally understand. It is finished.
320 million years ago, marine organisms lived and died in a shallow tropical sea. They could not know what they were becoming. 65 million years of geological transformation, 2,000 meters of burial, heat and pressure.
and then a drill bit in the Saudi years ago, 75 years ago.
Today, a Saudi engineer manages the same reservoir on a tablet computer. AI optimizes what...
The oil in your car's tank, where did it come from? Perhaps from a Ghawar well drilled in 1965.
The empty quarter, the largest sand desert on Earth. Hiding beneath its dunes, the energy. This is how oil is extracted from the desert. From geology to drill bit to pipeline.
Para mí sí es como una señal de que tenemos que trabajar más como por hacer comunidad, porque al final del día la comunidad es lo que nos salva. La comunidad es la que nos levanta.
That concludes our look at the strategic importance of these fields. For more in-depth analysis and documentaries, make sure to subscribe below.
Watch next how Iran extracts its oil from the Persian Gulf and the shadow fleet that carries it to China. The connected story.
End card.